Hi, so in this video, we are going to do an introduction to organic chemistry. First, we're going to talk about good fats and bad fats. So there are two types of fats, saturated fats and unsaturated fats. Saturated fats are come from animals. They're whole milk, cheese, butter, ice cream, red meat, and vegetables, coconut and palm oil sources. And then there are unsaturated or heart-healthy fats. They come from vegetable oils such as canola, olive, or peanut, nuts, avocados, tuna, and salmon. So those are different sources they come from, but the main difference between them are their structures. So if you look here, you can see that their structures are different. Saturated compounds have all single carbon-carbon bonds. Right here, you can see that they have single bonds between carbons. So unsaturated fats have one or more double bonds between their carbons. And a double bond is indicated by this double line right here between two bonds. And we'll go over what that looks like a little bit more. But that's the difference between saturated and unsaturated fats. So what is organic chemistry? Organic chemistry is the study of carbon and hydrogen containing compounds and their reactions. Organic compounds contain one or more carbon and hydrogen atoms, and they're mainly composed of just 6 non-metallic elements: carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus. Our body is mostly composed of organic compounds. You can see here that we have 65% of our body is oxygen, 18.5% is carbon, 9.5% is hydrogen, 3.2% is nitrogen, and then all of the others only makes up about 4% of us. So the chemical composition of the human body is mostly organic. Organic chemistry in everyday life. Here are some examples of organic chemistry or organic compounds. Paper is made up of cellulose, which is an organic compound. Nail polish is made up of nitrocellulose and butyl acetate. Candles are made of wax or tallow. Fabric are cellulose, nylon, rayon. Soap are fatty acid salts. Gasoline are mixed hydrocarbons, so organic compounds that just have hydrogen and carbon. Different smells and tastes we have come from organic compounds, just such as fruits, fish, and mint. Different medications like aspirin, Tylenol, decongestion, sedatives, insulin, addictive substances, caffeine, nicotine, alcohol, narcotics. Hormones and neurotransmitters are organic compounds, such as adrenaline, dopamine, serotonin. Food, carbohydrates, proteins, fats, and vitamins. And genetics, so your DNA and RNA are also organic compounds. Even though organic compounds only contain a few elements, like carbon, hydrogen, oxygen, nitrogen, sulfur, and phosphorus, the unique ways that carbon can attach to form molecules leads to millions of different compounds. Approximately 95% of all known compounds are organic compounds, and most biological compounds are organic as well. So hydrocarbons, I already talked about this, but hydrocarbons are compounds that contain only carbon and hydrogen atoms. Carbon has 4 valence electrons and achieves an octet by forming 4 covalent bonds. Carbon atoms can form single, double, or triple bonds. So this is our Lewis dot symbol for carbon. We have 4 valence electrons, so 1, 2, 3, 4. And we can have 4 bonds from carbon, and remember they are covalent bonds. So the different ways carbon can bond: 4 single bonds, and this is what you see in alkanes and cycloalkanes. one double bond. So this is a double bond. And two single bonds. You see these in alkenes and aromatic hydrocarbons, and one triple bond and one single bond. And those are what you see in alkanes. So this is shows you the class of hydrocarbons. So we have hydrocarbons, they only contain carbon and hydrogen. And we have alkanes. You have alkenes with double bonds, alkynes with triple bonds. These are called what's called aliphatic hydrocarbons. So aliphatic hydrocarbons, alkanes, alkenes, alkynes. Then you have aromatic hydrocarbons, which contain what's called a benzene ring. And your aromatic hydrocarbons is this structure right here. So you have one type of aromatic hydrocarbon, then three types of aliphatic hydrocarbons. So to practice, specify whether the following compounds are organic or inorganic. For each organic compound, indicate whether it is a hydrocarbon. So go ahead and look at these, pause the video, work on them, and then when you're ready, come back and we'll go over it. So this first compound, we have carbon, hydrogen, oxygen. These are all nonmetals, and these are the main elements of organic compounds. This is organic. Sodium and chloride, this is a metal and a nonmetal, and there's no carbon or hydrogen in it. This is inorganic. HCl, there's no carbon or hydrogen. This is organic. C3H6, there's carbon in it. This is organic, and it's a hydrocarbon because there's only carbon and hydrogen in it. Fats are organic. They have carbon, hydrogen, and oxygen in them. And CO2, even though it has a carbon in it, it is not organic. It is inorganic. So different physical properties of hydrocarbons. So the carbon-carbon single bond and carbon-hydrogen bonds are nonpolar covalent, and therefore hydrocarbons are nonpolar compounds. Nonpolar molecules interact through dispersion forces, the weakest of intermolecular forces. So IMF is intermolecular forces. So this is the reason why hydrocarbons with 4 or less carbons are gases at room temperature. They have lower boiling points than compounds with similar mass, and hydrocarbons are also hydrophobic. So they do not mix, or they're immiscible with water. So you can see here, this is a hydrocarbon in water. They do not mix. This is like putting oil in water. They don't mix. The physical properties, methane is the smallest of the hydrocarbons. Its melting point is negative 182 degrees Celsius. Its boiling point is negative 164 degrees Celsius. It is a gas at room temperature. Pentane is where you get to see it not be a gas at room temperature. It is a liquid at room temperature. And so as you increase your number of carbons, to increase carbons, your boiling point and melting point increase as well, because you have more bonds you need to break in order for that molecule to boil or change state. So you can see here, this is another picture. This is methane, ethane, propane, and butane. This has 1 carbon, 2 carbons, 3 carbons, and 4 carbons. The larger molar mass has the higher boiling point. So as you increase the number of carbons, you're going to increase your number of hydrogens as well and the molecular mass, and you're going to increase your boiling point. So in summary, organic compounds are compounds that contain one or more carbon and hydrogen atoms. Every carbon atom contains 4 bonds. The 4 types of hydrocarbons are the alkanes, alkenes, alkynes, and aromatic hydrogens. Remember, the alkanes, alkenes, and alkynes are called aliphatic hydrocarbons, and then you have aromatic hydrocarbons. Hydrocarbons are nonpolar and interact by dispersion forces. Hydrocarbons also have lower boiling points than compounds of similar mass. And hydrocarbons are miscible with aqueous solutions, so they don't mix with water.